just jump in here to some examples. Oof. Already not liking some of my decisions here. Oh well, we'll just do it this way. We'll just see how it goes. Okay. Sure. Okay. So, our goal here is to sketch the graph of this function right here, g of x, all right, that I've given us. Now, there's a lot of different aspects that we want to analyze here before we're ready to just jump right in and sketch the graph, okay? So, and these are things that you will need to be able to do too when it comes to your turn to, sketch these graphs and things, okay? So some of the things we want to identify. So it may be helpful to identify the domain first, okay? Once we identify that domain, we'll then identify any vertical asymptotes or holes, okay? Because remember, the domain restrictions, right, directly classify into either being a vertical asymptote or a hole for these particular rational functions, okay? We've had other domain restrictions that we've seen before, when we did like the square roots and stuff like that, because we don't want to take square root of negative, but there's no square roots here. It's all, the domain restrictions are going to be like from dividing by 0, right? And so any of those numbers we want to then, exclude from our domain, and then those exclusions will become, again, vertical asymptotes or holes in our cases, okay? And then from other thing we want to do is identify any horizontal asymptotes or slant asymptotes, okay? And then probably finding some zeros would be a good idea too, okay? And if we need to, we'll then find some additional points. Okay? So these are like kind of, I would say, the 4 main things that we've now, looked for, okay, or found. So, number 1, the domain. Okay? What are our domain restrictions going to be here? What x values are going to give us problems? 1, okay, yeah, because if you look here, x minus 1, right, if that were equal to 0, right, so we're just going to say x minus 1 equals 0 here, and so we get x equals 1, right, when we solve there. We also don't want that 2x plus 3 to equal 0 either, right, and so we can subtract 3 from both sides. We get 2x equals negative 3. We'll divide both sides by 2, okay, and so we get x equals negative 3 over 2. Okay, so these are our 2 domain restrictions. These are our 2 domain restrictions. All right, and so then we'll just go negative infinity to negative 3 halves, union negative 3 halves to 1. Whoops, forgot my u. Ugh. And then 1 to infinity. Really big u there. Okay. So there's our domain, right? And again, what is that? We just set the denominator equal to 0. It was already factored, so we can just go ahead and set each factor equal to 0 there, and we got those. So this x equals 1, this x equals negative 3 halves, those will then directly become either a vertical asymptote or a hole. Okay? So I guess I can zoom in on it. I'll zoom in here on this section there, right? If that helps some. Okay? Now, let's take a look at these 2 domain restrictions, the 1 and the negative 3 halves. Okay, I'll tell you right now, one of them is a vertical asymptote, one of them is a hole. Okay, Which one is the vertical asymptote? Which one? The negative 3 halves, okay? And Julian, how are you able to tell that that was the right answer? Or did you just guess it? Ah, you had your graphing calculator. Okay, so, and that's a legitimate way to analyze it, right? We have the graphing calculator. It is a tool available to us. You'll be able to look and see, we have a vertical asymptote there. So let me go ahead. I'll type that in, all right, just so we can see what Julian was seeing there. Okay. Be careful how you type this one in. You're going to need to use like a set of parentheses for, like, you're basically going to want to type in your calculator like this. One full set of parentheses around the numerator, one full set of parentheses around the denominator too, okay? I know it's a lot of parentheses, but you want to make sure you type it in right, and you don't want the calculator to misgraph it, or else you're going to be in trouble, okay? So we graph it, okay? So perfectly legitimate there. Obviously, if we have to pick between positive 1 or negative 3 halves for this vertical asymptote, well, clearly it's the negative one, right? Because it's on the left-hand side of the axis there, okay? What else, though? What else about our function here? How can we just tell by looking at the function that that negative 3 halves is going to be a vertical asymptote? What about our function here? Sure. So actually, let me ask the question a bit of a different way. So which factor down here, which factor gave us negative 3 halves as an answer? The 2x plus 3, right? Okay. Do you see 2x plus 3 in the numerator? No. So in other words, right, this negative 3 halves, right, it only will make the denominator 0. It will not make the numerator 0, right? This negative 3 halves, you don't see its factor up here, so the numerator will not be 0 if you plug that negative 3 halves in. Right? You'd have to see another 2x plus 3 up here for that to be 0 in the numerator as well. So this only makes our denominator 0. That means it's a vertical asymptote, right? So VA at x equals negative 3 halves. Now, which factor gave us the x equals 1 here? The x minus 1. And what do you see in the numerator? Another x minus 1. So this 1, right, is going to give us a 0 in the denominator, but at the same time, it also gives us a 0 in the numerator. Okay? And so we have a whole at x equals 1. Okay? A whole is like a point, right? It has a single location, all right? But it's like a non-point, if that makes sense. Okay? It has coordinates, right? We have the x coordinate for the point. I'll show you how we're going to get the y coordinate in just a second here. All right, so we have the x coordinate for the whole, all right, but it's a non-point. When you draw it on your graph, you're going to put an open circle. Okay, you're going to put an open circle. Okay, I'm going to hold off on showing you how to do find the y coordinate for the whole in just a second. We'll continue on here to our next stuff, though. All right, so next we want to identify any horizontal or slant asymptotes. This is exactly what we talked about yesterday. Okay, and if you forgot, let me see if I can pull it up here real quick. I have it right here. Okay, it was these things. We were looking to see the degree of the numerator, degree of the denominator, and compare it, right? And then you could have these options. Okay, you could have a horizontal asymptote at 0, or the lead coefficient ratio, or you could have no horizontal asymptote, and you might have a slant asymptote. Okay, so that's what we talked about yesterday. We have to look at the degree. What is the degree of the top of the numerator here? 2. What's the degree of the denominator going to be? 2. So it's the same when the degree of the numerator is the same as the degree of the denominator, then you have a horizontal asymptote at y equals lead coefficient of the numerator divided by the lead coefficient of the denominator. So it's the ratio of the lead coefficients. So what will the lead coefficient of the numerator be? If you were to multiply it out, what would the lead coefficient be? 4, yeah, 4, and then the 1 there, so 4 times 1 give you 4. Okay? What's the lead coefficient of the denominator going to be? 2. Yeah, 2 times 1, 2. Yeah. So it's going to be y equals 4 over 2, or you can just say 2. So horizontal asymptote at y equals 2. Okay. If there's a horizontal asymptote, is it possible to have a slant asymptote? No. They are mutually exclusive. Mutually exclusive. Okay. All right, and then for the zeros, that's where we set our function equal to 0. Okay? So in this case, it'll be 4x plus 2 times x minus 1 over 2x plus 3 times x minus 1 equals 0. Okay? But of course, a fraction only ever equals 0 when what part of the fraction is 0? A fraction can equal 0 only when what part of the fraction is 0? The numerator or the denominator? If the denominator is 0 were undefined, that wouldn't be equal to 0. It's when the numerator is 0. Okay, so you set your numerator equal to 0 there. We can forget about the denominator and just set the numerator equal to 0. Okay, like that. And so we get 4x plus 2 equals 0. We get x minus 1 equals 0. So I'll subtract 2 from both sides there. 4x equals negative 2. Divide both sides by 4. X equals negative 1/2. Everyone's favorite fractions. Okay? And then we'll add 1 to both sides here. Okay. And we get x equals 1. Sorry, one more time, Haley? Right, we have to throw out the 1 as a 0. Why do we have to throw the 1 out as a 0? It's, yeah, we have a hole there, and it's not in our domain, right? So it's okay to say there's a hole at 1 because that means there's a non-point there, right? There's not a point there. It's not in our domain, so this 1, we have to throw it out. So it's only a 0 at negative 1/2. We only have 1 0 there at negative 1/2. Okay? So that's putting it all together there, folks. That's putting it all together. Okay? I will not make, so I'm not going to make you remember, like, I will ask you for domain, for vertical asymptotes and holes. I will ask you for horizontal asymptotes and asymptotes. I will ask you for the zeros. I will ask those questions. You will need to know what to do in order to find those things. Okay? That's your job. I will ask you what to look for. You will need to know how to look for and how to find those things. Okay? That's your job. Okay? You will have to be the, do your analysis and stuff like that. All right, so let's graph this thing. All right, we're going to sketch a graph of this without using our graphing calculators. So, draw an x and y axis here. Okay. You don't really graph domain. I mean, it's going to show up in the graph, but we don't really graph it, right? We're going to infer, at first use the vertical asymptote and the horizontal asymptote to help guide us here. So let's see here. 1, 2, 1, 2. Okay, I'm going to graph the vertical asymptote at negative 3/2. So here's negative 1, here's negative 2, negative 3/2. Be right in between here, and I'll put it in red to make it stand out. So right in the middle between negative 1 and negative 2 will be your vertical asymptote. Okay. I'm going to label it just for the sake of the notes and stuff like that. Okay, there's our vertical asymptote. We also have a horizontal asymptote at 2, so I'm going to graph that in as well at 2. So 1, 2, that's right here. Just like that. Okay, so we took care of the vertical asymptote. We took care of the horizontal asymptote. I'll go ahead and graph the 0 as well. We know how to graph zeros, right? It's just, that's where it intersects the x-axis, right? And so at negative 1/2, well, there's negative 1, so negative 1/2 will be right here. So there's a 0. Okay, there's our 0 right there. Okay. I have one more point I want to graph, though, and that is this hole. Now, we know the hole occurs at the x value of 1, but we don't know what the y coordinate is, right? So we know we have the hole at 1, so we're going to have it somewhere, along in here, but we don't know what the y value is. How can we figure out the y value? Well, we're going to take our function here. Let me scoop this up. There we go, right there. We're going to take our function. And what do we normally do? What do we normally do if we have an x value and we want to find its matching y value? What would we do? What's that? Plug it in, right? Plug one in. But if I plug one in, we get 0 over 0, right? And that creates a problem because like we can't graph 0 over 0, right? So like what we normally would do, right? If we have an x coordinate and we want to find a matching y coordinate, we plug it in to all these x values here. But if I do that, I'm going to get 0 over 0. However, what can we do with these x minus 1s? You can cancel them. Now, if I plug in 1, will I get 0 over 0? No. So let's see what we do get. So 4 times 1 plus 2 over 2 times 1 plus 3. Okay? 4 plus 2 is going to be 6. 2 times 1 is 2 plus 3 is going to be 5. So 6/5. We have a y coordinate now. So the whole, okay, really has coordinates 1, 6/5. Okay? 1, 6/5. So we take our function, we cancel it out, then we substitute in the 1. Okay? Notice we could have canceled this thing out earlier, right? But I didn't, and I did that on purpose because we wanted to keep these pieces in our function, okay? Because it's part of our original function. But for evaluating the whole, for finding what the y value for the whole is, we need to cancel it out. Okay, in order to do that. So now we'll plot this point, or this non-point. So 1 is right here, and then 6/5. Well, there's 1. That'd be 5/5. So I'll just go a little bit more, and I'll put an open circle there. Oops, sorry. Okay, so there's 1. There's 1 5/5, or 1, 1, right? 1, 1. That's 5/5. I go up 1 more fifth, we'll say, roughly, and there's my open circle. Okay? And so now I can, I think I have enough information. I can just kind of, connect, and the whole counts as a point, so you can kind of use it to connect. And we'll just go like that. Okay, now, this is not the full graph yet. We still got to look over here and see if we need to graph anything, but I have no points over here, right? I got nothing, all right? If we had to guess, where would you guess the graph would be? Up in the above the horizontal asymptote or below the horizontal asymptote? So there's more graph to graph over on this side. If you had to guess, would you guess it would be above the horizontal asymptote or below the horizontal asymptote? It's going to be above. It's going to be above, yeah. But if you need convincing, right, just pick another x coordinate. So let's see here. There's -1, there's -2. Let's go ahead. I'll pick -3. Okay, I'm going to plug -3 in to my original function up here. Okay, so I'm just going to evaluate that. So this is just going to like an additional point. I need one more point here. So I'll just do g of -3, which would be then 4 times -3 plus 2, -3 minus 1, 2 times -3 plus 3, and then -3 minus 1. Of course, if you don't want to do this math, you could also just go to the table in your graphing calculator and get some more points that way too. Your choice. Okay, so let's see here. That's -12 plus 2 is -10. -3 minus 1 is -4. 2 times -3 is -6. Plus 3 will be -3. -3 minus 1 is -4. -4s will cancel, and so I'll have -10 over 3, -3, which is 10/3, which is 3.3 repeating. Okay. So -3, 3.3 repeating. So -3, 1, 2, 3, and a third would be like up a little bit more. So there's our point. Okay, and we'll just kind of then use that one point to kind of get the rest of the graph. Okay, so there it is. That's a lot of work. One graph. Yeah.
How many problems
thinking like 2 maybe? So 2 like this. 2 like this. Yep. So I will ask you, right, I will say, here's your function. What's the domain? What's the, find any vertical asymptotes or holes, find any slant asymptotes or horizontal asymptotes, find any zeros, and then graph it. I'll say all those things. You'll need to know what to do. Sorry? Have time to practice right now? No? Not sure? All right. Keep going. All right. Let's do one more. Yep. Sure. Let's do one more here. And this one I'll change it up a little bit here. Make it a little more interesting. Okay. Here we go. Graph f of x equal to x squared plus x minus 2 all over x plus 3. Okay. X squared plus x minus 2 all over x plus 3. All right, so let's look at our domain first. Okay. What x value is going to give us problems here? -3. Okay. You guys see that, right? -3 in my denominator there is going to give me 0, right? If you want to check to make sure, just set your denominator equal to 0. X plus 3 equals 0, so subtract 3 from both sides. X equals -3, right? Okay. And so then the domain will be -infinity, as Julian said there, to -3, union -3 to infinity. There's only one x coordinate that causes problems, right? There's only one factor down here, right? It's just x plus 3. So -3 we exclude. And then I'll go ahead this way. How about then vertical asymptote slash slant asymptote? Oh, that's wrong. Vertical asymptote slash hole here. Right, one or the other. Okay. Well, it's kind of hard to tell here, but we can check, right? So again, the question is, does this -3, does it give us 0 over 0, or does it give us some other number divided by 0, right? So plug -3 in. -3 squared, 9. Plus -3, well, now we're at 6. Take away 2, we're at 4. Okay? So f of -3 here, if I plug -3 back in, I get 4 over 0, which indicates we have a vertical asymptote. Vertical asymptote at x equals -3. Okay? Very exciting. All right. Now we'll identify any horizontal or slant asymptotes. Okay. And for that, we look at the degree, right? This is what we talked about yesterday. The degree. Okay. What is the degree of the numerator? 2. What's the degree of the denominator? 1. So do we have any horizontal asymptotes? No, because the degree on the top is bigger than the degree on the bottom. So when do we have horizontal asymptotes? When they have the same degree, that means you take the ratio of the lead coefficients. So if this was a 2, it would be 1 over 1 for your horizontal asymptote. If the degree of the bottom is bigger, so if this were like a 3, it was x cubed here, then your horizontal asymptote would be 0. But since we have a degree on top is 2, degree on the bottom is just 1, it's 1 more though. So that means we have a slant asymptote. And how do we find slant asymptotes? Long division. Okay, so yes, you might need to be able to do long division tomorrow on that little quiz too. Okay, so what times x gives us x squared? X. And x times 3 is 3x. Okay, we'll subtract those quantities. But of course, instead of subtracting, I like to add the opposites. Okay, so the x squareds cancel. X plus -3x is going to be -2x minus 2 Okay? And what times x gives me negative 2x? Negative 2. So negative 2 times x is negative 2x. Ooh, negative 2 times 3 is negative 6. Subtract those. Okay? So add the opposites. The 2x's cancel. Negative 2 and 6 makes 4. 4 is my remainder. Sorry, I know this is like ridiculously small. I ran out of space there. 4 is my remainder, but what would we do with the remainder? Throw it out. So there's the equation of my slant asymptote. Okay? It's just the answer without the remainder. So y equals x minus 2 is your slant asymptote. Okay? All right, we still have to find the zeros, right? And the zeros occur when the function equals 0. So x squared plus x minus 2 over x plus 3 equals 0, right? But again, it's really just when the numerator equals 0. And of course, to solve this equation, what do we have to do? We gotta... So one option, you could graph this, right? You could graph this if you wanted to. Graph this and see where it equals 0. That's one option. We can factor this, though. We need two numbers that multiply to make negative 2, but add to make 1. So two numbers that multiply to negative 2, add to make 1. It'll be 2 and negative 1. 2 and negative 1, or negative 1 and 2. Okay, set each factor equal to 0. Subtract 2 on both sides. Add 1 on both sides. Okay. Are either of these numbers part of our domain restrictions? Is negative 2 part of our domain restriction? It's not, right? Negative 2 is okay. Is 1 okay too? Yeah, 1's okay as well. Not restricted from our, it's in our domain, right? It's in our domain. Negative 2 is in here, right? Negative 2 would be in this one. And 1 is also in this one. All right. So there are all of our pieces. Let's sketch the graph. No holes in this one, right? No holes in this one. Again, draw your vertical asymptotes first. Or draw all your asymptotes in first. That are like the bones. Okay? So... So put some tick marks down, and now I'll graph those vertical asymptotes and the slant asymptote too. Okay, vertical asymptote at x equals negative 3. 1, 2, 3. There's our vertical asymptote. Okay. The slant asymptote is this. We got to graph this. What is the slope of this? So slope-intercept form, what's the slope of this line? Ooh, yeah, we haven't graphed a whole lot of lines, did we? We didn't do much practice with this. What's the slope of this line? It's mx plus b, right? mx plus b. What's the m in this equation right here? 1, or 1 over 1. What's the b? Negative 2, yeah, okay, so we go over to here. Negative 2 is the y-intercept, so put a point at negative 2. Okay, m, the slope is 1, so up 1, right 1, put a point, 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 up 1, right 1, put a point. Down 1, left 1 as well. And so that's going to be our slant asymptote. Y equals x minus 2. And then let's see here. We have our zeros to graph. We have negative 2 and positive 1. So negative 2, positive 1. Okay. -2 and +1. And so our graph then, well, I'll hold off there. So how to connect these, right? Well, we'll go like this. We're going to kind of come in, but then we have to kind of like turn a corner here and go back up through that other 0. So it looks something like this. Okay? I mean, so the idea is, so what do I want to see you do? I want to see you go through the zeros. I want to see you, as you get close to I want to see you approach the asymptote there and approach the asymptote there. That's it. Okay? That's all I need to see you do. Now, we're going to have another part of our graph down here too, but I didn't really might leave myself enough space. So it's going to be something like this, though, down here. Okay? Something like that down there. Okay? So there's the actual graph, something like that. Okay? So, things that your graphing calculator will be able to help you with. Things that your graphing calculator will be able to help you with. All right? Your graphing calculator will be able to help you with the domain as long as you have like nice whole numbers. All right? To like, you know, for your like vertical asymptotes, your holes. All right? So like for example, you know, Ava likes to look at her table, and that's fine. You can look at the table and look for errors in your table. The one catch, though, like I told Ava, said to you guys, right, is that you got to be careful if you have fractions. If there are fractions that are restricted from the domain, that's not going to show up in your table. Okay, so you have to be careful with that. But if they're nice whole numbers, they will show up. Okay. You can also use your graphing calculator to help you identify vertical asymptotes because those are very clear, right? They're going to show up very easily here, right? And you can see vertical asymptotes, right? But holes are hard to see. Your calculator will not show you those very easily. They'll show up in the table as an error potentially, but you know, that's it. Horizontal asymptotes, they will also show up pretty straightforward, and slant asymptotes as well. Horizontal asymptotes will be easier for you to identify because they're just nice straight line, just nice horizontal lines. Slant asymptotes, you'll see that they exist, but you're gonna have a hard time coming up with the actual equation unless you do the long division yourself. And then zeros, those will be super easy for you to find in your graphing calculator because your graphing calculator has a zero command. All right, so if you are one of those people that do all graphing calculator all the time, you'll be able to get some of these pieces, zeros for sure, right? You'll get some of the domain, you'll get some, you'll be able to identify vertical asymptotes, but you're going to miss holes potentially, and then you might be able to get horizontal asymptotes, okay, but slant asymptotes you're probably not going to be able to get, okay? So really, it's got to be a hybrid. You'll have to be both, you and the calculator working in tandem, working together to help you graph this stuff, okay? So keep that in mind. All right. So I want to give you guys now some time to practice these because I can only talk so much. You guys need to try these on your own and struggle with them some. Okay. So let me give you some problems to look at here. Let me see. Patrick Slant when he comes back. Hello? She is not. Not present. No, I'm not. Yeah. Bye. Okay. Well, darn. I thought I had some good problems here to go. All right. Sorry, folks. One moment here. Let me see if I can figure out. Some problems earlier. No, that's not gonna help either. I'm just going to give you guys two here. I just have to come up with some here on my own. Okay. So I don't have anything out of the book I can give you there because we kind of like used all the problems that we've done that are in there. So here's what I'm gonna have you do. All right, so I'm just gonna put these up on the board here. So number one, I want, again, the directions are graph. F of x equals so graph, that means, you know, domain, root of asymptote slash whole, horizontal asymptote slash slant asymptote, zeros. Okay? So see what you can do with that. Okay? like graph paper to do those with? I want some graph paper. Got some graph paper.